finally to the last problem for the 2012 option test number 5. Part A. Find the set of values of k for which the improper integral converges. Well, first of all, let's refresh ourselves. What is an improper integral? It's any integral that goes to infinity. That's what makes it improper. It does not have definite values. Now, in order for it to converge, then as it goes to infinity, it has to be approaching 0. All right, so to evaluate this, we're going to just evaluate the integral. Take a look at it, x times ln x to the k power. Now, in order to find that integral, we're going to have to use some u substitution. So let's let u equal ln x. Du dx is equal to 1 over x. Cross multiplying, x du equals dx. So let's come back over to this integral and replace dx with x du. The x in the denominator is still there. Ln x has now been replaced by u to the k. Well, you can see the two x's cancel, so we're just left with the integral of u to the k. Well, let's rewrite that as u to the negative k du. So now we just use our basic integration technique. We're going to increase that power so it becomes u to the negative k plus 1 power over the new power, negative k plus 1. At this point, let me get rid of that integral sign. We just integrated it. Don't need that anymore. Let's replace our u with what it was originally, which is ln x. We have ln x to the, let me put my parentheses in there, negative k plus 1 power over negative k plus 1. And our limits of integration were infinity, 2 on the bottom. And I'm going to rewrite this a little bit different. See that negative k plus 1, if I flip the numerator to the denominator, remember what that does is it changes the power from a positive power to a negative power. In other words, the negative k plus 1 is already down there in the denominator, and when I flip ln x, it's going to make the signs of that power different, or just the opposite, so it becomes k minus 1. Now, on this improper integral, we want to think what value of k is going to make this whole thing equal 0 as you go to infinity. All right, so this just takes a little thought. Well, let's see. If that's going to go to 0 as you go to infinity, that means that the denominator has to be getting larger and larger and larger. Well, ln x, when you put infinity in there, that's always a large number. So if to keep that large, you would just have to be raising it to a positive power. If it were a negative power, it'd flip it back to the top, which means it would not be approaching 0. We want the denominator to get larger and larger and larger, so the complete fraction is approaching 0. So in order to keep that large ln x, which is going to infinity on the bottom, k minus 1, the power, has to be greater than 0, because we want it to be a positive power to keep it getting larger and larger and larger on the bottom. And just taking the 1 to the other side, k has to be greater than 1. Now we know it has to be greater than 1 and not equal to 1. It can't be greater than or equal to, because if you tried to put a 1 back in for that k, you get a 0, which is undefined. So when k is greater than 1, this whole expression as x goes to infinity, natural log of x gets larger and larger and larger because it's being raised to a positive power, which means the denominator is getting bigger and bigger and bigger, which means the whole fraction is getting closer and closer to 0, which means it converges.